Hello friends, I am Rohit Chadar, and you are watching your favorite mathematics channel, Maths. So in today's video, we will learn a very significant theorem of mathematics, that is, we have to prove the irrationality of square root of 2. So let's start. So the statement of our theorem is prove that root 2 means square root of 2 is a irrational number. So before starting the proof of this theorem, let's have a look at definition of rational or irrational number. So here we have the definition of rational numbers. So rational numbers are those numbers. Here we have the term numbers, not integers. So rational numbers are numbers that can be expressed in the form of p over q, where p and q both are coprimes. So let's have a look at the meaning of coprime. The meaning of coprime is that the numbers p and q are integers such that they don't have any common factors between them, and q is non-zero. It means any number m that can be expressed in the form of p over q, where p and q both are integers and q is not equal to 0, then such type of number m will be a rational number. And those number which cannot be expressed in the form of p over q, those numbers are called irrational numbers. So now I think you must be aware with the definition of both rational and irrational numbers. So now let's start our proof. So here we have our proof. In this proof, we will prove the irrationality of square root of 2 by using the contradiction method. So let's first assume that square root 2 is a rational number, and after certain steps we will prove, or we will show, that our assumption is wrong by showing some unusual results. So let's start proof. So at first we assume that square root 2 be a rational number. If we assume this, then we can write square root 2 in the form of p over q, where p and q both belongs to set of integers that we read sometimes before in the definition of rational numbers. And another condition for square root 2 to be rational number is that the numbers p and q both must be co-primes. It means p and q should not have any common factors among them. And now we square this root 2 equal square root of 2 equal p upon q both sides, so we get 2 is equal to p square over q square, and after multiplying q square both sides we can get p square equal to 2q square. This implies that 2 divides p square, or 2 is a multiple of q square. Then this term 2q square, it must be an even number. Since 2 is the multiple of integer q square, so p square is an even number. It means that p must also be an even number, because square of only even numbers is even. Since square of p is even or multiple of 2, so p must also be a multiple of 2, or 2 must divide p. So we can write p equal to 2a, where a is some integer. It means we can write p in the form of a even number, that is 2a. Again, squaring both sides, we get p square equal to 4a square. This implies that 2q square. From here we have value of p square equal to 2q square, so we can substitute it here and our statement becomes 2q square equal to 4a square. On dividing by 2 both sides, we have q square equal to 2a square. It means 2 divides q square, or the square of integer q is an even number. It means that q must also be an even number. Since square of q is even, so q must also be an even number, because square of only even numbers is even. So let's move a little more further. So we were here, and since q is a multiple of 2, so we can write q equal to 2b, and here we have written p equal to 2a. In the initial part, we have assumed that both p and q are coparents. It means p and q doesn't have any common factors among them. But now we have concluded that p is a multiple of 2 and q is also a multiple of 2, and 2 is a common factors of both p and q. So our assumption must have been wrong, that square root 2 is an rational number, so square root of 2 must be an irrational number. So it's our proof complete. Thanks for watching this video. Like this video and subscribe this channel for more mathematics videos. Thank you.